Good evening, friends. This is Manish Khandelwal. I am a mechanical engineer, and the details of my experience are mentioned at the bottom of this slide. As I mentioned last time also, the name of this channel is changed to Factory Forward TV. I have another channel, Brainy Builders, where I address mathematics and science subjects for students up to class 8th and 9th. Today's presentation is on a very interesting topic and a very important one, and that is SPC, Statistical Process Control. This topic is a bit lengthier, so I am dividing this topic into two parts. In first part today, I am making presentation on normal distribution curve. Now, what is a process? In a process, inputs like material, information, resources, they are converted into desired output by taking help from series of predetermined and interrelated and or interconnected activities following some set standards. Now, to monitor, control and improve this process by using few statistical tools and techniques is statistical process control. And most common statistical tools are control charts, which look like this, Pareto diagram, which looks like this, and some process capability studies. These three we shall be studying in our next presentation. Let's understand two important terms, mean and variance. What is mean? Mean is nothing but average of a data set. How do we calculate? Just we add all the values in the data set and divide it by number of values in the data set. For example, there is a data set having 5, 10, 12, 8, 6, 22, 15, 30 and 28. These are the data. So to find the average or find the mean of this data set, we need to add all these data, 5 plus 10 plus 12 plus 18 plus 8 plus 6 plus 22 plus 15 plus 30 plus 28. So if we add all these data, we get 154. The number of values, if you count it, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So count all values are 10. So addition is 154, count is 10. When we divide 154 by 10, it is 15.4. That means the average or the mean of this data set is 15.4. Simple. Next term is variance. Variance gives us the spread of data from mean. Now it is measured in square unit of original data. That means if it is in meter, then the variance will come in meter square. If it is in kg, the variance will come in kg square. How do we calculate this? It is calculated by taking average of squared difference between each data point and the mean. How do we do it? Variance, this is population. When we say population, that means all the data we shall be considering. Sigma of xi is each data, minus mu is the mean, whole square divided by n. So 5 first data minus mean 15.4 whole square plus 10 second data minus mu again mean 15.4 whole square plus 12 third data minus 15.4 whole square, and like this up to the last 28 minus 15.4 whole square, and then of course we divide everything by 10, and here we get 71.44 is the variance. This is population. If we take only the sample, then in the formula this n will become n minus 1. So just we need to just remember it. For population, it will be divided by all the counts n, and if we are taking for sample, it will be n minus 1. So in this case, n minus 1, 10 minus 1, it is 9, and the sum was 714.4 divided by 9. In that case, the variance was coming 79.38. Next is standard deviation. Like variance, standard deviation also gives us the spread of all points from mean, and it is calculated by taking square root of variance. Simple. So the key difference between standard deviation and variance is the unit of measurement. Variance is expressed in units squared. If you can recall last slide, we said if the data set is in meter, then variance will come in meter square. If the data is in kg, the variance will come in kg square. It will come in square as it involves squaring the data between data point and mean, each data minus mean, and whole square. Standard deviation, on the other hand, is expressed in the same unit as the original data because we are taking the square root. So standard deviation is the under root of variance. That means variance was sigma xi, xi is the data, minus mu is the mean, whole square divided by n. And two formulae for standard deviation. For population, of course, we'll be dividing it by n, and for sample, we'll be dividing it by n minus 1. Now, what is standard deviation and normal distribution curve? The basic interpretation of standard deviation: a large deviation indicates spread of data point from mean. So that means if the spread is more, for example, if we see these two graphs, here the spread is more. That means the standard deviation in this case is more than here. Now, what is a normal distribution curve? This normal distribution curve is known as bell curve also because of its shape. A normal distribution curve basically is a probability distribution curve. The curve is symmetric. That means the left hand side and the right hand side are mirror image. The highest point is known as mean. The curve is characterized by mean and standard deviation. It is very important to know that most of the data do not perfectly conform to normal distribution curve. There are certain distribution rules in a normal distribution curve for a process to follow, which is not practically possible for a process to follow all the times. Let's study those rules. When we are doing a study, statistical study, we have to make sure that there are no significant variation and or unpredictable pattern. If we observe any significant variation or unpredictable pattern, we need to sort out those before we start any statistical study. In statistical study, there is a rule called 68-95-99 rule. Basically, it provides a rough estimate of the proportion of data that falls within certain range of standard deviation from mean. So if we go as per this rule, then 68.27% of the data shall fall within mean plus minus 1 sigma. Sigma is standard deviation. So mean plus minus 1 into standard deviation. If our data set is following normal distribution curve, then 68.27% of the data shall fall within this range. Similarly, in a normal distribution curve, 95.45% of the data shall fall within mean plus minus 2 sigma, plus minus 2 into standard deviation. And further, 99.73% of the data shall fall between mean plus minus 3 sigma. So this is a rule for normal distribution curve. Once again, these percentages are specific to data that follows a normal distribution. That means the data symmetrically and precisely follow the bell-shaped curve. If it is not following that, if the normal distribution is not there, then percentage mentioned above, that is 68, 95, 99, may not hold good. And there may be some other percentage in mean plus minus 1 sigma, plus minus 2 sigma, and plus minus 3. Now let us learn how to make a bell curve in Excel. So what we do, for example, this is our data 1, 2, 2, 5, 6, 6, blah 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 up to 48. So what we do first, we take the mean average A from A to AD. So we take the mean of this data, and that mean comes to 23.73. Then we take the standard deviation of this data by simply using the formula STDEV P. This is population A and up to AD, from A to AD. So we are taking standard deviation using this formula STDEV dot P. We can use STDEV dot S also if the data is, we have to take sample data, and we are taking population data. So STDEV dot P A to AD. So standard deviation of this data is 13.98. Now we need to follow the normal distribution of this data. Again we take a formula, normal distribution is equal to norm dot dist. This is normal distribution, norm dot dist. Then we take each data. For example, for first one we say A comma mean, this will be common. Then standard deviation population, this will be common, and then false, and then we close the bracket. So we fix this formula here and drag it. So each time all other values will be same except the data value. This data value will change, and then you have the distribution values here. This is the normal distribution of this data. Now what we do, simply in Excel we insert a chart, and chart shall be scatter with smooth line. Once you click here, you will be getting this curve, this bell curve. This is how we make a bell curve on Excel. So that was how we make or generate a bell curve in Excel. We follow a different method to generate a bell curve in PowerPoint. This bell curve is generated in PowerPoint. Let us take one example to understand normal distribution better. Assume that the selling price of potatoes being sold by a vegetable vendor are normal distributed. That means the selling prices are following normal distribution. The mean selling price is rupees 40 per kg. So this price is rupees 40 per kg. This is mean. The standard deviation is rupees 2 per kg. This is one standard deviation, plus 1, minus 1. This is rupees 2 per kg. Then as per rule 68, 95, 99.7, or a normally distributed data, which it is, mean plus minus 1 sigma, mean is 40, plus minus 1 sigma is plus 2 minus 2, plus minus 1 into 2, that is 42 and 38. So this value is 38, mean minus 2. This is 42, mean plus 2. So there are 68.2% chances that the prices of potatoes shall fall between 38 and 42. Similarly, mean plus minus 2 sigma, mean plus minus 2 sigma plus 2 minus 2. Mean plus minus 2 sigma is 40 plus minus 2 into 2, that is 44 and 36. So this is 36 and this is 44. As per that rule, 95.45% chances are that the prices of the potato shall fall between 44 and 36. So there are 95.45% chances that the potatoes price shall fall between 36 to 44. Similarly, mean plus minus 3 sigma, that is 40 plus minus 3 into 2, that is 46 and 34. This is 34, this is 46. So there are 99.73% chances that the prices of the potatoes shall fall between 34 and 46. And then of course we have mean plus minus 4 sigma also, and plus minus 5 also, plus minus 6 also. Now friends, I think I have been able to make things clear as far as normal distribution curve is concerned. I shall be taking up the control charts, Pareto diagram and the process capability study in my next presentation. Thank you very much.